Good morning. This is your lesson for Tuesday, our second week in virtual learning. We are going to be doing more reducing fractions with our greatest common factor. First, we're going to do our problem solving. So I'm going to read it. I'm going to tell you to set a 5-minute timer to be able to solve it, and then I'm going to show you how to solve it. So I'm going to read it to you. This is our problem solving activity for the day. 5/8 of the staff at a local aquarium are male. What fraction of the staff is female? Again, I want you to underline the important information in your document. You're able to underline. Box or highlight in yellow what might be a key word to help you know if it's add, subtract, multiply, or divide. And then if you can draw a picture, please do this. This is a really great strategy, especially to help you try and understand how to solve this problem, okay? Again, set a 5-minute timer, pause this video, try the problem solving, and then I'm going to show you how to do it, okay? All right, welcome back. I'm going to show you how to do the problem solving activity. Again, this needs to be filled out on your Google document that you turn into me for your classwork in order to get a complete grade, okay? So we have 5/8 of the staff that are male, okay? We need to figure out how many of the staff are female or women. There's a piece of information that we kind of need to imply here, and you should know this, but this is why I'm doing this kind of as a review as well. Okay, so if we have 5/8, that's 5/8 of the entire staff. So if we're thinking about the whole staff as a fraction, we would write the fraction as 8/8. Because 8/8 equals 1 whole, right? So that's the entire staff. So if this is the whole staff put together, male and female, and we know that 5/8 are male, we need to figure out the rest that are female. So are we going to be adding, subtracting, multiplying, or dividing? We're going to be subtracting. We are going to be subtracting 8/8, which is our 1 whole, right? Subtracting 5/8. Can we subtract as is? We can, because our denominators are the same. But we don't subtract the denominators, we keep that denominator the same. We subtract in our numerator, 8 minus 5. If you're not sure, put 5 in your brain, count up to 8. 5, 6, 7, 8. 3. Okay, 3/8 of the staff are female. Please make sure you're writing this in a complete sentence in order to get the full credit for question number 1 for the problem solving, okay? While I'm erasing this, just checking in to see, I hope you had a really good snow day. I canceled school just for you so you can go play in the snow. Not true, it was already canceled. But I hope you had a good time maybe being outside in the snow, maybe getting cozy by the fire, reading a book, watching Netflix. If you know any good programs or television shows or movies to watch, I don't have Netflix, but if you know any others that I can access, you should contact me and let me know. I'm starting to run out of what I can actually watch or what I know about watching. So, okay. Good enough. Okay, so for our lesson today, come on. Okay, so for our second question, I'm now in question number 2 that I do. Can we reduce 5/10? 5/10. The way that we're going to figure this out is we are going to find if there is a GCF of 5 and 10. Remember, thinking blank times blank equals or doing the factor rainbows. Okay, 2 numbers that multiply together to equal 5, I always start with 1. And 5. Are there any others? There aren't. That's my only 2 factors of 5. Easy peasy. Factors of 10. Always start with 1 and 10. Any others? 2 and 5. Okay, so now I'm looking in both lists and trying to figure out which number is the largest number that both lists have in common. Well, both lists will always have 1 in common. That's not the GCF. 1 is never going to be the GCF to reduce fractions because it's just going to give us the same fraction. But I have 5. 5 is my GCF. So I'm now going to take this 5/10. And in order to reduce this fraction, I'm going to divide by my GCF in both my numerator and my denominator, okay? My new simplified fraction in its lowest term is going to be 5 divided by 5 equals 1. 10 divided by 5 equals 2. 1/2 is my simplest term, okay? That is for question number 2. Question number 3. Can we reduce 4/8? All right, 4/8. Can we reduce 4/8? Well, we're going to see if we have a greatest common factor or a GCF for 4 and 8. If I do, then I can reduce it by dividing in both my numerator and denominator. So let's go ahead and find our GCF first. Always starting with 1 and then 4. Any other factors? Well, 2 times 2, so I'm going to just write 1, 2 there. And those are my factors for 4. Okay, factors of 8, always starting with 1 and 8. What two numbers, when multiplied together, give me 8? 1 and 8, when multiplied together, give me 8. 2 and 4, give me 8. Any others? Nope, those are my factors of 8. Now, I'm going to look in both my lists of 4, my factors of 4, my factors of 8. Besides 1, oh, I have 2 in common, but I want the greatest number. 4. 4 is also in common, and that is going to be my greatest number that both lists have in common. So I'm going to take 4/8, and I'm going to divide in both my numerator and denominator. So I'm going to divide by 2. Oops, sorry. Divide by 4. My bad. See, teachers make mistakes too. Divide by 4. Divide by 4. 4 divided by 4 is going to give me 1. 8 divided by 4 is going to give me 2. Again, if you're not sure, you can flip this around. What number times 4 gives me 8? What number times 4 gives me 4? Sometimes it's easier to think in multiplication. But 1/2 is my answer for question number 3. Right? Let's go ahead and look at question number 4. Something a little bit easier to erase. Okay, good enough. All right, can we reduce 3/10? Let's look at it. 3/10. Okay, I'm going to find the GCF, greatest common factor of 3 and 10. If there is a greatest common factor, I can reduce. If there isn't, then I can't reduce. So, factors of 3. What two numbers, when multiplied together, give me 3? Well, I'm going to start with 1, and I'm going to start with 3. Those are my only factors of 3. 10, factors of 10, 1 and 10. 2 and 5. Those are my factors of 10. Okay. Are there any numbers besides 1 that both lists have in common? Nope. So I cannot reduce this. So 3/10 cannot be reduced. Again, even though they have 1 in common, if I divide this by 1, Let's go ahead and do it. Divide by 1. I'm still going to get the same answer. I'm going to get 3/10. So it cannot be reduced. It's already in its simplest term. Okay? Question number 5. Cool. Okay, question number 5. Can we reduce 8/12? Okay, doing our GCF, greatest common factors of 8 and 12. Always start with 1 and the number, so 1 and 8. Boop. 2 and 4. Boop. Okay, 12. 1 and 12. 2 and 6. Oop. A little more space. I also have 3 and 4. So 1 times 12 equals 12, 2 times 6 equals 12, 3 times 4 equals 12. Okay, these two lists have multiple numbers in common, but I have to find the greatest common factor. I have 1, but we already know that 1 can't be a GCF, or greatest common factor. I have 2, but there's a higher number, which would be 4. So I'm going to take 8/12 and divide by 4. So I can reduce 8 divided by 4, or what number times 4 gives me 8? I know 2 times 4 gives me 8. What number times 4 gives me 12? I know that's 3. So my reduced fraction is going to be 2/3. Okay? I did provide a multiplication chart in the materials section. It's very clearly labeled multiplication chart. Please use that multiplication chart this week to help you, especially if you are not 100% sure with your multiplication and division facts, okay? I will leave that up there for the remainder of the virtual learning. Okay, so while I'm erasing this, this is the time where you can pause the video, and I want you to work on questions number 6 and 7 so that you get some practice, and then I will come back and show you how to do questions number 6 and 7, and you can check your answers, okay? Set like a 5-minute timer, 5 to 10-minute timer, depending on how long it takes you to work. Do questions number 6 and 7, and I'll come back and show you how you do it, okay? See you in a bit. Okay, so I'm back. I'm going to show you how to do questions number 6 and 7. Question number 6, can we reduce 3/5? 3/5. Going to do the GCF of 3 and 5. Remember, what two numbers when multiplied together give me 3? Well, I have 1 and 3, and I have 1 and 5. Those are my only factors of 3. Those are my only factors of 5. Besides 1, remember, 1 cannot be my GCF to reduce a fraction because we get the same fraction if we divide by 1. Are there any GCF? Is there a GCF between 3 and 5 that we can reduce this fraction? Nope. So, no. No. We cannot reduce. This fraction we cannot reduce. It is already in its simplest term, 3/5. Okay? Hopefully that's what you got for an answer. I wanted to throw in a little curve. All right. Question number 7. Can we reduce 6/9? 6/9. All right. Finding the GCF to be able to reduce. If we can reduce 6/9, remember what two numbers when multiplied together give me 6? What two numbers when multiplied together give me 9? Always starting with 1. 1 and 6. Are there any others? There are. We have 2 and 3. It's 1, 2, 3, 6. Okay? What numbers when multiplied together give me 9? Well, I have 1 and 9. And I have 3 times 3. I'm just going to write 3 once. My GCF cannot be 1. We have 3 though. 3 is the highest. So we're going to go ahead and use the GCF 3 to divide and reduce our fraction. Okay? Dividing by 3 in both my numerator and denominator. 6 divided by 3 is going to give me, or thinking, what number times 3 equals 6? Well, I know 2 times 3 equals 6. What number times 3 equals 9? 3. Right? So your answer, yes, you can reduce for number 7. It is 2/3. That is your answer. If you got these correct on your own without my help, then you should be good to go for the do now. If not, please go ahead and review the lesson so that you can, you should be good for the exit ticket. If you didn't do as well as you wanted with these 2 questions, maybe review the lesson again so that you can get that perfect score on that exit ticket. Those are being graded, okay? That's going in for your quarter 4 grade. Okay, I'll leave this here, but go ahead and do your exit ticket, and I will see you back tomorrow. Bye, guys.